Is any real number exactly 1 less than its cube?
No. Wait, what?
Well, let's read the solution and see what it says. It says, we answer this question by applying the intermediate value theorem in the following way. Any such number must satisfy the equation x is equal to x cubed minus 1, or equivocally, x cubed minus x minus 1 equals 0. Hence, we are looking for a zero value of the continuous function f of x equals x cubed minus x minus 1. The function changes signs between 1 and 2, so there must be a point c between 1 and 2 where f of c equals 0. And so what they're talking about is this graph. And I'll plug this in the calculator and we'll go over it more. We're basically, this is the function graphed, and we can see clearly that it crosses 0. But how can I prove that? Well, we know that it's a continuous function because there are no restrictions in the domain. So we can choose an a and b. In this case, your textbook chose 1 to be a, 2 to be b. Those are the x values. But what we're looking for is y. Well, y equals 0 is the solution to this equation, okay? And so by looking at the graph, we see that occurs between x equals 1 and x equals 2. Does that make sense? And that's why they arbitrarily chose 1 and 2. So because the function is continuous, and if we define the 1 and the 2, then clearly somewhere in between the two there's a point that exists, which is f of c equals 0. And you would say, well, duh, right? But now we've proven it formally, right? Does that make sense?
No.
No? All right. Let's graph it. So watch Mr. Adams. I'll graph it. So here's what we're saying. We're saying that, and let me read it again. Is any number exactly 1 less than its cubed? Is there one number that exists that is 1 less than its cubed? So 1 cubed is 1. 2 cubed, let's write some of this stuff down. Maybe that'll help make sense. So it says, is there any one real number that is 1 less than its cubed? So let's look at that. 1 cubed equals 1. Okay. Well, give me a second. And then we know that 2 cubed is equal to 8. Well, is there any one cube? Is there a number that I could cube that is exactly 1 less than its cube? Well, if I plug in 0 cubed, I get 0. So 1 is equal to itself. It's not 1 less. This one is not 1 less. But is there a number that exists? Well, clearly it would be kind of challenging to figure this out. So what we did is we tried to take a more general approach. What does that mean? That means that there's some number x out there that is equal to its cube minus 1. Okay? So now let's do a little bit of math.
Is it asking if there's one specific number or all?
Well, we're going to solve it and then maybe it'll make more sense. So what they're saying is there a number out there that is equal to its cube minus 1? See, if I plugged 1 in here, 1 equals 1 cubed minus 1, well, that's not true because it's actually equal to 0, right? So that didn't work. If I plug in 2, I get 2 cubed minus 1, and that's equal to 7. So, and if I plug in 3, so that didn't work. If I plug in 3 cubed minus 1, well then that's 27 minus 1, which is 26. So if this number exists, it's got to be between 0 and 7. Does that, or 0 and 2, right? X has to be between 1 and 2, is what I meant to say. Does that make sense?
Yeah.
Okay. So what I want to do is I generalized it and I said x has to equal x cubed minus 1. Is there a value for x that satisfies this equation? Well, what they did is they just moved the other x over and set it equal to 0 and said, well, let's solve it. If that's the case, then I just need to solve this equation. And we suspect that the answer would live between 1 and 2. All right? Well, x cubed minus x minus 1 has no domain restrictions, and so we can assume that it's a continuous function. So we graph it. So when we graph it, to solve this, you would solve it like any other equation. You would say x cubed minus 1. Now this is not what you want to do on your homework, but I just want to show you this. Okay? And we're going to go from negative, well, let's go from 0 to 2, because that's what it is in the textbook. And so it does cross the x-axis, which means y equals 0. Now they're not asking us what the value is, they just want to know if it exists. So one thing that I could do is I could look and I could go, all right, here, wait, did I enter that in correctly? Oh, no, okay, I get it now. So this has to occur between 1 and 2. Because when I plug 1 into this equation, it looks a little different because we rewrote the equation. But it has to occur between 1 and 2. Because 1, I have a negative value, 2, I have a positive value, and what I'm looking for is y equals 0. Now the textbook isn't asking me specifically what it is, it just wants to know if it exists. Well, I could say yeah, because according to the intermediate value theorem, I have from 1 to 2 is on f of x, and f of x is continuous. Well, I shouldn't even say f of x is on f, and f is continuous from 1 to 2. Okay? So I could say 1 comma 2, these are the x values, or a comma b as the theorem defines. Okay? And I could say that f of a was equal to, what was it, negative 5 or negative 1? Negative 1, and f of b was equal to 5, right? And I could write it like this. I could say f of 1 equaled negative 1 and f of 2 as equal to 5.
Why is it equal to 5?
Because that's the equation. Because if I 2 cubed is 8, minus 2 is 6, minus another 1 is 5, right? So by IVT, because what we're saying according to the IVT is this. We're looking for f of c equals 0 exist.
Cool.
How do I know that? Well, because we know that every value from negative 1 to 5, every y value from negative 1 to 5 is defined because it's a continuous function. So then we would say that c must live where? 1 and 2. So that's the formality of it. I mean, we could graph it and look at it. We could actually even solve it. Right? It's nothing for me to go into my calculator and solve it. But that's not what it's asking. It wants us to formally prove it. Does that make sense?
What's IVT?
Intermediate value theorem. And we will solve for C eventually. First we just need to know how to prove that it exists.